I'm Michael Dawson. I'm a senior software developer with IBM. My day job is I work on Node Core out in the community, but at home I like to experiment with IoT, and I built a few things which I'm going to talk to you about today. What I want to do is I don't have a lot of time, but what I want to leave you with is a little bit of knowledge about IoT, MQTT, and how Node is a really great language to do your IoT type projects in. And enough knowledge and hopefully excitement to get started in building some of your own projects. So just to start out with, a little bit of terminology. If you've been in this session and track all day, you may have already seen this, but for those who haven't, I'll start out. First of all, what is the Internet of Things? It's really a network of connected devices. So the things are just actual little devices that can run code. These devices can provide you data, so they can be sensors like temperature sensors, actuators that tell you whether doors are opened and closed and so forth. And they can also be controlled, so you can send messages back to those devices. So for example, you can say, I want to turn on and off a light switch, something like that. And if you want to read more, there's a good website that'll give you a good definition of the Internet of Things. MQTT is the MQ telemetry transport, and it's a nice lightweight publish and subscribe system where you can publish messages and consume messages as a client, and it makes it really easy to communicate between those devices. It's a really nice lightweight protocol. It has a very small footprint, so you can get it easily into small devices. I've heard things like you can have an MQTT implementation in something like 80K, so pretty small footprint. The messages themselves can be very small, so if you have low bandwidth, it's also good for that kind of environment. Based on the spec, the smallest message could be as small as 2 bytes, depending on what you sent. Of course, if you send more data, like a larger message, you're going to have a larger overall message as well. And it's pitched, if you go to the MQTT.org site, it's actually pitched as a way to connect up the Internet of Things. So I just want to start out by telling you a bit about MQTT itself. So there's a few basic concepts. The first one is topics. So topics are the way that you register your interest or you publish messages. And those topics are really just a set of strings separated by slashes. So for example, in the example that I'm going to show you, which is a home alarm system that I built using Node, MQTT, Raspberry Pi, Docker, I've got a few of my topics here. And so for example, one, house alarm status, is simply a topic that'll publish messages to say, what's the status of the alarm? Is the alarm activated? Is the alarm on? Is the alarm off? Similarly, something like house alarm zone, if you think of an alarm system, they have one or more zones. And so it's a topic that when the zone status changes, the zone is triggered or the zone is reset, you're going to publish a message to that particular topic. Over here, the house 2262/1/2, in the project that I've done, I use 433 megahertz devices. And there's a standard protocol, the 2262, 227 protocol, which is often used to communicate those. So I just map those directly into my topics so that when a particular device sends a message, a wireless message, I'll end up publishing a message to that particular topic. The other interesting thing you can do with these topics, you can see that there's one with a plus and there's one with a number sign there, a hash mark. The plus basically says I want to match one element, so I could do A plus B/C, and I'll get everything which has that as A and C in those positions, but has anything else in the middle one. And the hashtag is basically match everything down below. So if you want to say I want to listen to all the messages on a particular topic under a particular tree, you can do that as well. So topics, that's the first part. The second part is the messages themselves. Again, MQTT is a very lightweight protocol, not very complicated. Those messages can be strings and they can be anything that you want. The two examples that I have here, again, map back to my alarm system. The first one is something that you would see in, when you're using that 2262 or 2272 protocol. It's actually a tri-state protocol where you can have 0, 1, or floating. And basically the device just sends out a message that says, there's, I think it's 8 bits or 12, actually 12 that say, floating, 11000, and that identifies a particular device. And if you'd opened up the device, you can actually set a bunch of jumpers, which will actually set what's going to be floating. Each bit is going to be floating, 1 or 0. But you can also have other things. And the other thing I do in the alarm system is I actually have a service listening on a particular topics and publishing to topics to take pictures. So when the alarm goes off, You can take pictures of what's going on, hopefully catching your intruders. And so your messages can be something like that, which is basically the identifier for a picture, which you then want to display in the GUI when you're saying, okay, let's take a look at all the pictures that the alarm has captured. So those are the two key concepts, the topics and the messages. The last one is the quality of service. So MQTT provides 3 qualities of service. Level 0 is basically just do your best effort. You're going to publish your message. It may or may not get there. Most of the time it will. And for things like temperature sensors, that's perfectly fine. If you're sending out the temperature every 30 seconds, it really doesn't matter if you're going to lose the occasional message. It's got the lowest overhead, the lightest weight, and so it's good to use unless you need one of the higher levels. QoS1 is deliver at least once, so that makes sure you're going to get your message, but you could get your message multiple times. And again, for some cases that's okay, but there's other times where you don't want to have the same message more than once, in which case you can move up to quality service 2, which guarantees you're going to get your message once and only one time. So those are the different levels you can get. The other thing, of course, is that if we're connecting these devices, we need to be able to do it securely. We don't want just anybody to be able to connect into overall network. So MQTT does provide, the standard kind of security features that you'd expect. There's user IDs, device IDs, passwords. More importantly for me, though, is you can use TLS, so you can encrypt the tunnel, and you can use certificates. So you can actually say only devices that have these particular certificates installed can actually connect into my network. So that's pretty secure. It's important to be able to have clients and brokers across different platforms. So MQTT uses the concept of a broker, which is really the mediator. So you have multiple clients that connect to your particular broker. Clients can publish on particular topics or subscribe to particular topics. And it's the broker that manages connecting up the people who are publishing and the people who are listening on the topics. It's easy to get a client for MQTT across all sorts of platforms. So because we're interested in Node, of course, there's the MQTT NPM package you can just install and use, and I'll show you how to use that a little bit later on in some of my slides. But FAO is also another project which gives you native clients written in C, and they run across a whole bunch of different operating systems and platforms. So it's easy to get clients. Similarly, it's easy to get brokers. Mosca, again, is one that's written in Node, and you can connect up to it. I've shown up here a screen capture of me just starting it up. So it's, again, an npm install, start up Mosca, and you've now got a MQTT server you can connect to, publish, and subscribe to messages. And even if you don't even want to do that, there's actually IoT services out there, like on IBM's Bluemix. There's an IoT service where you can register devices and then publish and receive messages. So you can very easily get set up so you can publish and receive the messages between your devices. So now we'll talk a little bit about the example I'm going to take you through to illustrate how much fun and how easy it can be to do all this with Node. My approach was to glue the devices together with MQTT. So the devices may speak different protocols, but in the end, what I wanted was something that ends up just publishing a message to an MQTT topic. So if my door window sensor goes off, I don't need to necessarily worry about, in my main application, interfacing with that piece of hardware. I'm going to get a message posted to a particular topic, and then I can do the right thing. And so the MQTT is kind of the glue that glues all the pieces together, and then I built the smarts in Node itself, and Node is a nice fit to go together with that. It's all open source, so if you're interested in the various projects that I put together to glue all these pieces together, I'll talk a bit more about the overall architecture on the next page. It uses Raspberry Pi, a number of different devices, and even the last project, the RxTX temp board, there's actually a KiCad Gerber files, so you can go and sort of build your own PCB boards here if you want to. If anybody has a Raspberry Pi, I'm willing to give one away, so at the end you can come by and maybe put your name in a hat or something like that if you want to build your own. And in addition to the home alarm system I'll talk a bit about, there's also some other projects there like the home dashboard where it's just a very simple Node application that shows you what's going on in the house in terms of temperatures, how much power your house is using, those kinds of things. So the overall architecture, in the home itself, the alarm system is a Raspberry Pi, but none of the smarts are actually there. It really just acts as a relay. So there's a number of processes running in the Raspberry Pi, Pi 433, TX, and RX. So those are basically processes written in C that use the FAO clients. And they talk out through 433 megahertz through some transmitters and receivers, and I'll show you the circuits for those fairly straightforward. And their job is simply to either listen for RF messages, interpret them, and then publish that message happened on a particular topic. Or the Pi43TX basically takes a message, an MQTT message, and says, okay, I'm going to send out a message over RF based on that. There's also a connection to a USB camera, so there's a process that talks to that USB camera, again connected through MQTT, so that when it gets a message on MQTT, it says, please take a picture. It goes off and takes that picture for you. When it's finished, it publishes back on another topic saying, hey, I've just taken your picture. Here's the name of the picture, which lets you then later find it on your website. And then there's a number of devices, which I'll talk a little bit more about, that are communicated through 433 megahertz. Out in the cloud, so this is all outside of the house, over an internet connection. There's an MQTT server running in a Docker instance. There's a web server running in another Docker instance. I think it was Apache 2. That's used to store the pictures that the alarm system takes. And when it does take a picture, it just SCPs them up to the particular web server. There's the MQTT connection, of course, that publishes and basically lets us get the messages from the house to the overall controller. That's again over through MQTT and secured, of course, with TLS and certificates, so not just anybody can connect in. There's another Docker instance that is running the alarm system itself, so the thing written in Node that I'll show you a little bit more about. And of course, I wanted things like notifications, so if the alarm goes off, it can actually send me an SMS message on my phone. To do that, I go out to Twilio, which is a service that lets you very easily send SMS text messages to yourself. And then finally, the Node application also provides a GUI through WebSockets that lets you connect in and actually get a panel, much like a regular alarm system that you'd be familiar with the ability to arm, disarm, what's going on for each of the zones, the status, and so forth. And that browser also reaches back to the web server to get the pictures as part of the overall UI. So, one of the things I want to highlight is that, Node and MQTT, they're just a really nice fit. And it's one of the reasons I think it's one of the best languages to do your IoT systems interaction with MQTT. They're both very asynchronous, just like the real world. Like an alarm system, we're based on events. So something happens, the door opens, we set an event. Node is a great fit because I can very easily basically say, register for something to happen when that event happens. And when you look at the code here, you can see that I just start out by basically saying I want to connect to my MQTT server. So that's the very first line. I just really need to provide a URL, a number of options. Those options can include things like my pointers to my certificates and so forth. Once I've done that, I want to basically say, now that I've connected, I want to register that when certain things, like I actually connect, I want to subscribe to particular topics. So as I mentioned before, those topics are just strings, and they can be things like the status of the alarm. They can be particular zone is going on and off. So I just register by saying, client up to subscribe to the alarm status topic, the zone prefix topic. And I'll talk a little bit more about that one because there's a little more going on there. It takes pictures, so there's a topic that says, hey, a new picture has been taken. And then the zone mapping topic that says, okay, I want to actually subscribe on all the zones that I've registered for the alarm system. And so you can see it's really easy to set yourself up. Then when the next part that says client on message, it just says, when a message happens on any one of those topics, I'm going to run a particular function. Very nice, asynchronous, and a really good fit for Node. Similarly, on the send side, I can really easily just say, I want to publish to a particular topic this particular message. So that's just a string, and then I can make the message whatever I want. In this case, it's like I'm just publishing take to say, please take a picture, and we can go on. So how do we actually interact with the physical world itself in the particular alarm system? So you can see just two very simple circuits. These can be easily wired up to your Raspberry Pi. It doesn't take more than a few pins. And you can see here I've got the overall look. Here was my first prototype where I wired things together, and then here's after I actually sent off and had the PCBs built. It's just a little bit neater, but does exactly the same thing. And then the software on the other side has a few interesting things, like you're reading pins. You're using Linux to reading the state off of some digital I/O pins, and some people have mentioned in earlier topics, the resolution isn't quite as much as you would on a small microcontroller, so you have to be a little bit more careful in terms of not doing all of your work on the interrupt handler, but trying to pass that off to another thread which is actually going to process the messages once you've received them. This gets into, this code then shows a little bit more specific, like I said, in terms of the zone mapping. So what happens when one of those zones goes off? And one of the reasons I used 433 megahertz is because it's really easy to get devices. So this is a simple device. It's a door window sensor. You've probably seen something like this. You open the door, the window, it'll go off. You can get something like this for $3 or $4 off of eBay. You can easily also get motion detectors. You can get even smoke alarms that are going to send messages. And you can very easily then set it up so that when you get a message that's published on a particular topic, so this is saying, okay, when I get a particular topic, if it's defined in my zone mapping, so it corresponds to one of the zones that I've set up for my alarm, I'm going to then republish it saying, okay, well that particular zone was triggered. And then the next piece says, oh, and if the alarm is actually in the arm state, and I've got something that's triggered one of my zones, I'm going to publish to the topic that says the alarm status has now been triggered, and that message will then be captured and processed to say, oh, well, the alarm went off. I'm now going to do things like send messages and so forth. And down here shows a little bit of the mapping. So in this case, I've mapped in to say, okay, well, the particular topics that I have, house 2262/1, 2, 3, 4, 5, I've actually used the jumpers in my devices to map to 1 through 5, and they map to zones, 1, 2, 3, 4, not necessarily in the same order, and they're the names that I've assigned to those particular topics. The other thing the alarm does is it takes pictures. So there's a USB camera connected to it. And again, it uses the same thing. So here, basically, when the alarm goes off and we want to start taking pictures, one of the other things is, your house is probably, if you're not there, it's dark. So I want to be able to take pictures in the dark. I got an infrared illuminator. Unfortunately, there weren't any devices which would actually allow you to turn the illuminator on and off. So I built one myself. It's actually a pretty simple circuit that you can use. There's chips that understand these protocols, and you just hook up a receiver. And so that's what I did. And so now I can actually call this IRN function, which basically says, publish a message to a particular topic. It sends out the wireless message to the light, turns it on. Then you publish to the topic saying, please take a picture. It does, and then it publishes back the name of the picture that it's taken. The Node application itself, and you can go look on the GitHub repo to look at the code itself, but this is the UI that it provides through WebSockets. You can basically see that you can arm, disarm, you can ask it to take a picture. It gives you links to the recent pictures that were taken. It shows you the status of all the zones. You can see a log of what's happening. You can take a look at those pictures, and in fact, you can connect up multiple cameras to have different views, one infrared, one non-infrared. And of course, because it's web-based, you can connect to it on your cell phone as well. A native client would be nice. I haven't written one. If anybody was interested in writing one, that'd be great, but I haven't quite gotten there. The other thing on the cell phone is you can get SMS messages. So it sends you the messages. Twilio is a really nice client that lets you send yourself an SMS message with very, very little work. This is basically all the code that you need in Node. And you can send up messages which end up showing up on your alarm. So it's kind of neat to, every time you open up your door, you end up getting a text message saying, hey, somebody just entered your house. So when you put all these pieces together, now, hopefully I've got you a little bit interested. If you want to deploy your own, where are you going to deploy the cloud components? Well, you can easily do that for free. One example is where you can do that is IBM's Bluemix, which is our platform as a service and Docker container and virtual machine offering are basically our cloud offering. So, in the Cloud Foundry app, which is basically the platform as a service, you can easily publish the Node components, so the Node controller, the broker. Equally, you can publish those as Docker instances in the Docker container option. You could also publish the web server there. And if you don't want to do that, and you can also use the IoT service, which basically provides you the pieces to glue devices together without having to worry about the actual individual servers and stuff like that yourself. So I think I'm actually now at exactly my time. I'm just going to show you the live. So these are a few, of ones which I typically have on my desktop. Well, let's see, it didn't arrange so nicely. But there's the alarm console, which you can get from anywhere. Here's the data that's coming from my house right now, how much power it's currently being used, the temperature in the basement, humidity, furnace room. And it's easy to extend these things to, I'm working on an Arduino-based device, so you can use the same RF communication, but then have it turn on and off your air conditioner, all those kinds of different things. So that's all I had. If there's any questions. Sure. No, we're a pet-free house. The sensors, the motion detectors claim to be pet safe, but I don't have any pets to be able to test them. My kids are big enough that they definitely set them off. Oh, sure.
How do you, if you have multiple sensors reporting to the one base unit at once, how do you not mix up the two incoming messages and just kind of garbled output?
So all the messages, the 433 megahertz is actually, it's if you collide, you collide. So the devices all send out multiple messages. So they'll actually send the same message out 10 times in a row and multiple times. So you will get collisions, and you'll basically ignore those. But otherwise, each individual message, as long as it's time separated, is different. And different protocols have different shapes of the pulses and so forth. They'll have checksums on them and those kind of things. Okay, if that's it, thank you for coming.